Good evening, Professor. This is my personal timetable. Uh, what I have done in previous week, I have attended the research group meeting. But I had always attend Monday offline biomedical physics class, and we are about to give MMIC third assignments. So I was studying about that, and simultaneously I'm studying about my research also for medical sensing application using different reference noise source and researching more new papers about it. And the current week I'm going to uh, do it's about uh, I'm going Monday on daily basis. We have to attend a research group meeting, and on Friday we have to attend biomedical physics two offline classes, and on Tuesday I have to submit MMIC third assignment. So I'm working on that also, and I'm simultaneously going to work on my research also. So that's it for my plan week. And what I have gone through is that this today I'm going the first few slides is like I'm just recapping all the previous slides, previous week slides. So it's a quick recap uh, about this paper. So first of all, the paper title was Design and Implementation of Novel Informametric Microwave Radiometer for Human Body Temperature. This was the title, and the abstract was it's a theoretical. It's like first of all, it's a detection device for human body temperature. It has advantage of like it is accurate, rapid, and non-contact. And hardware architecture of interferometric microwave thermometer uses 2 gigahertz band, and it has a phase shifter, error and coordinator demodulator, and auto correction detection functions also. And in this week I have studied many algorithm also, which I will describe detail in further slides, like correction algorithm which improves accuracy of the temperature measurement, and after correction phase is reduced from 40 degree to 1.4 degree Celsius, and then temperature changes to 0.1 degree Celsius. Voltage, of course voltage also change obviously in that case. And mean square error also we have find for water temperature. And further we had used inverse and multiple regulation algorithm, the bp algorithm, bp neural algorithm, which I'm going to describe in further slides. And this was the abstract part, and next is the introduction. In introduction I have studied that it is infrared detection technology. As I said before, it is non-contact rapid measurement human body temperature. It can measure body temperature of a person wearing a cloth also. It can monitor the body surface temperature, subsequent tissues of ICU patients within an appropriate distance. uh, Next is the it it has a positive contribution to uh, this COVID situation for prevention and control. And the major use of this technology is like a shopping mall, university. It's a rough temperature screening is there. The main advantage, it is non-contact measurement, wide measurement range, high temperature measurement speed, high sensitive. Disadvantage, it is penetrating detection is less, and long distance detection we cannot find accurate result in long distance, and it's high precious detection. Next, what I have studied in this, we I have studied gone through this evolution of radiometer. First, I'm going to start with 2009 to 12. What was there in what was the block diagram there in this 2009 to 12? In the between this year, they had improved the measurement using antenna and design probe. Antenna probe with directivity can radiate energy in directionals, as you can see in this um, this block diagram. There are two source, hot and source and switch calibrations. This is the front end part. In front end part there is isolator and RF AMP, and further it has a down conversion, high pressure filtered, and there is a mixture DQ, and then it connects with the if amplifier, then low pass filter, DC block, if LNA is there, then this antenna envelope detector will uh, give output to the DCLNA, and then the voltage output get, and when the refraction section goes in that, it has been divided to lower frequency circuitry and other part also. So this was done in 2009 to 12. Then after in 2015, around the Lee and Lang of University of Science Technology, they had carried out a contact and non-contact temperature measurement experiment on water. Then they had conducted a study on the temperature measurement of heart ablation in area in the cardiac radio frequency ablation surgery with C-band microwave radiometer. In 2017, Park and John, they had designed a total power radiometer with two reference load, and this shows a good performance consistency, and the temperature measurement is about 298.15 to uh, 316.29, which is, when you convert in Celsius, it gives a minus number, so which is not so appropriate with this result. um, so this was the evolution of the radiometer. And next, in this paper, the one thing I really like about that, they had clearly nicely mentioned that this is the hardware section and this is the software section. So the blue box describes the software section. I'm going to elaborate about more uh, for this software design. And the this is the design flow chart of novel informametric microwave thermometer. First, it is hard, it starts the, then it is divided in two sections. First is hardware design, and then the uh, software design. In hardware, it has been described in three section: high detective temperature measurement antenna, interferometric analog correlator, and RF front end circuit design of radiometer. This covers the hardware part, and next comes to the software. In that also we had three section. First is correction algorithm, then comes the how what mechanism they had used for calibration, and then comes the inversion algorithm, and then you can predict the temperature. Final step is that in the software past, first section is about correction algorithm offset error using microwave radiometer. In this, it is connected to a sine signal with frequency 5 gigahertz with power 0 dBm. And second, the main controller STM 32 controls the phase shifter to shift the phase by 90 degree step, and then a 2048 group of IQ channel voltage value are collected at each phase point. Finally, the results are stored in this phase path according to this VI and VQ. It has a certain equation like 10 into I 65 535 minus 5, and for VQ it's 10 into Q upon 65535 minus 5. And this equation is for is used for correction algorithm, and further we are going to use this equation for this correction algorithm for calculating this voltage and phase at each point, difference between the theoretical phase and the value. Now comes the point, the phase and the phase error of the system is obtained by averaging the phase error of the sample data. Then the phase shift, the value of the phase shifter is controlled to compensate the system phase error. After phase compositions, the relation between the voltage and the sampled value should be linear in this case, and then it can intercept with the offset error, and which creates the slope, as I will show the graph also about the how we are calculating the slope and everything, and the idle error offset slope and idle slope. And this table describes the voltage and phase value of the sample data. When temperature is about 38, what will if you keep the voltage 1.286, the phase will be 49.068. Correspondingly, every temperature and voltage has specific phase. You can go through with this table. And then comes this equation for calculating S idle, that is code max value minus code mean, and the positive reference minus negative reference. This is the correction equation of offset error and gain error. In offset correction, E offset and E gain correction is equal to S idle, which we get from this equation using this formula, and actual we have find with previous equation. And to calculate S actual slope, we are going to use this equation, this formula, that code receive my multiply by S idle and S actual, and upon S actual plus E offset corrections. So in this intercept and slope parameter are obtained by linear fitting method. In this they had used a linear fitting method, and gain error, offset error are corrected according to error correction method, and the corrected result of I channel is shown in this figure. This this is corrected result of I channel using correction algorithm, and this figure is about corrected result of Q channel using correction algorithm. And this as I showed you before also, there was a table that was sample table, and this is the real current value of voltage and phase error, and after correcting phase error and offset error, we have specific temperature with specific voltage, then the phase error will be like this. As I said before, after correcting after using this correction algorithm, temperature changes to 0.1 degree Celsius, and it reduces the influence of phase error and offset error, and it improves the temperature measurement accuracy. In this, after that, I'm going to explain one. This is the flow chart for correction algorithm. This is software design flowchart. How we have uh, designed a software design for a correction algorithm. This algorithm we have used, and this is the flowchart of correction algorithm. First, we have a set of collection data. Then we process that data at the second step, and after that we get a phase error. In phase error, there will be, of course, boolean value will be there. Result will be in form of yes or no, true or false, like that. If phase error is true, then it goes to a phase shifter. When the phase error is false, it directly goes to a gain error to check that gain error offset. This diamond shaped box is about for decision making. So for every flowchart we use for decision making, we use this diamond shape uh, symbol for decision making. Then when it comes to gain error, offset error, then again we check that it is linear fitting algorithm or not. If it is yes, then when we get an gain error in a form of true, we will go for linear fitting algorithm. If we don't get error, uh, then if it is false, then it directly corrected to the voltage. So this was the flowchart for correction algorithm we had used in for software design. Next this slide is about as I said, this is the second subtopic of software design. In this, design of calibration, how the calibration has been done, what mechanism has been used for microwave radiometer. In this, we the first as this is the block diagram of microwave radiometer with double reference load. And this algorithm is divided in step by step calibration and overall calibration. When the current is 50, the output microwave radiometer is 1.382 volt. When current is 75, the output will be 1.24 volt. And uh, uh, and uh, among this, uh, when the equivalent noise temperature, uh, this is to calculate the specific temperature reference. We are going to use certain equations which I have gone through with that paper. uh, for temperature reference, we are going to use this formula. For temperature reference, when we have a value, impedance value and reference 1 and reference 2 value, we can use this formula. And then when the temperature reference corresponding to 50, current is it has the output of 330.45 Kelvin temperature, and this is T1. And this was the 3 330.5, that is temperature reference 1 value. And when the current value is 75, it has a 29.291 0.31 K, and this is the temperature reference 1 value. for the gain, we are about to use uh, this sorry formula, and the basic formula V out minus V1 upon temperature reference 1 upon minus T reference, and to uh, input the value, and you will get the final result as a 0.01. This is when you will calculate this. After calculating your the resistance calibration equation, and you will get the calibration curve as like this: 50 is up and 70 is 9, using V for drawing, for plotting graph y equal to mx plus v. This is the formula for plotting this curve, and of course, for validation of data material at 28.30 degrees Celsius, what will be the temperature, specific MACT temperature, and corrected voltage. And we have certain sort of formula we have to use for calculating the brightness temperature of observing material by antenna, and for corrected voltage, for anti in is for radiometer, for calculating temperature radiometer. And this is first of all, the seventh table is about data of aluminum barrel and observing the material of overall calibration. What will be the temperature, MACT, and emission of temperature, corrected voltage according to this object, what we have used first, aluminum plate and observing material, and then corresponding temperature we have calculated, and then final corrected voltage has been used. In this we had emission temperature and corresponding voltage value, and then we had we have one equation using emission this value to A, and this is overall calibration equation, and voltage has been used, and this is uh, equation, this both are equation. Using this equation we had find the value of A using simultaneous method, which we had used in similarity chapter. It's a mathematical calculation, and when you solve this equation using simultaneous equations method, you will get the value of this A at this much and B this much. And then to plot this overall calibration curve, we had used this formula y equal to mx plus c. That was the formula for plotting this line for which is about aluminum barrel, and you will get the value of this, and this is the value of A and B, and this is after substituting this all the verifications, the overall calibration is, temperature is about 28.03 degrees Celsius. Okay, this is the last third section of this software design. In this we had studied about water temperature inversion algorithm, and in this we had used first of all, this is inversion algorithm. Inversion algorithm is used for determination of the relationship between the brightness temperature and the physical temperature. uh, for this we had a certain equation for using this inversion algorithm, we had used this equation, and in these two lines you will get to know what particular this stands for. TW stands for what, TW as TW stands for what, and what is TL. I have mentioned in this slide. TL is about like aluminum plate temperature. What is antenna temperature, like TN, and what is this KN about? It is a contribution coefficient of antenna. So by this way we have calculated this uh, TAP, um, like then to design this inversion algorithm, multiple regression algorithm has been used, and BP, as I said before also, I have studied BP neural network algorithm. In matrix form, it has a equation like TPA. It's in bracket T01 T0 T1 to T4 equal to T into theta. Next is about BP neutral network. As you can see in this, we have four layers like brightness, temperature, aluminum barrel temperature, antenna, and feeder, and then we had nodes of headings from H1 to H10. Then the physical temperature obtained. If there will be any error, then again we have to go back to the error back propagation. This BPA network uses this error back propagations method. In this we had used water temperature inversion algorithm. In this, the Spittis descent method to continuously adjust the weight and threshold of the network through the back propagation. As I have mentioned before, this error back propagation method to minimize the sum of the square of network error. Then this process continue until the error of the network output is reduced to less than 0.1 degree Celsius, and then the learning time set is advanced has been reached. In this is a set of example, like there is a 3 BP layer BP neural network is used to train 125 data set, which takes the round of 10,000 rounds, and means 10,000 nodes will be there, H nodes, and in that input variable of set brightness, temperature, aluminum plate temperature, antenna, and feeder, as I said, layer by layer. And then the physical temperature output is like physical temperature of the water. 29 group of test data of verification has been done. As you can see in this figure also, there is a the blue bar is about actual temperature, and the this, I think so, light yellow is about predicted temperature, and this the first graph is about the error, and this is the actual temperature and the predicted temperature, and which has been done till 28 times, and that's it. The result shows that using this BP neural network of at the water temperature 40 degree is higher than the 40 degrees Celsius, which has a mean square error uh, 0.334. That's it for the day. What I have studied, I have mentioned in my presentation, what I have gone through and what I have gone through with this, what I have learned. I have mentioned everything. uh, if there is any sort of comment or any suggestion uh, for my research, it will be good for my research. Thank you.